here are solids and how to name them. A solid has 3 dimensions, and so we're talking about prisms, pyramids, cones, cylinders, spheres. So, number 1, I want you to look at the base of this shape and know what shape is the bottom. And the shape of the bottom is a rectangle. And then it comes up to a point. Another way to know that it's a pyramid is to look at the shape of the sides of it. So all the sides are triangles. For a pyramid, the sides are going to be triangles and the bottom is a rectangle. The bottom is a circle and it comes to a point. That's called a cone. Here, the bottom is a triangle. But if you look at the sides, they're rectangles. And if you look, there are 2 bases. So when you have 2 bases, that's called a prism. When there's only 1 base, it's called a pyramid. So if I look here at number 4, how many bases are there? Well, there's 1 base, it comes up to a point, and all the sides are triangles. That is what a pyramid is. And then the bottom tells you what shape it is. 1, 2, 3, 4, 5. That's 6. That's a hexagonal. Big word. Pyramid. All right, 2 circles. Like a prism, because we have the base, 2 bases, but it's a special prism. We call it a cylinder. 6, it's a box, but mathematically, what's the bottom and the top? What shape are they? They're rectangles. We call it a rectangular prism. Or a box, or a Kleenex box. Here, the sides are rectangles, but the base and the top, it's kind of on its side. This is a trapezoid. It's trapezoidal. And it's a prism, because there's 2 bases, 2 trapezoids. This is a pyramid. What type of pyramid? Well, what's the shape of the bottom? This is called a square pyramid. Here, this is called a prism, because we have 2 bases. Each one, and if you count the number of sides, it's 5. This is a pentagonal prism. You could say pentagon prism, and that's good too. All right. We have a base that comes up to a point. The base is a triangle. This is a triangular pyramid as it comes up to a point. Here, we have 2 bases. They're both triangles. This is a triangular prism, like a piece of cheese or a ramp. Oh, a ball, right? Oh, a ball. What's a fancy word for a ball? It's a sphere. All right, turn the page. So we're going to find the surface area of these solids. That means 3-dimensional shape has faces. And if you put all the faces and find the area of each face and add it up, that gives you the area on the surface of the object. So we're going to try to have a shortcut to this. So for rectangular prisms, we have a shortcut for surface area. So we're going to go 2 times, and then we have the length and the width. So 2 times 7 times 13. We have 2 times 13 times 9, and then 2 times 7 times 9. And then put in your calculator and add it up. Where's my calculator? Let's see. Can you do it faster than me? 2 times 7 times 13. 2 times 13 times 9. Plus 2 times 7 times 9, big number, 542. For area again, we're going to square that. So 542 feet squared. All right, let's try it again. For a rectangular prism, so we're going to go 2, and then we're going to use 5 and 16. Then we're going to go 2 and use 16 and 10. And then we're going to go 2, and then which combination? 10 and 5. So all the combinations times 2. And then put it in your calculator. I get 580, and that's going to be centimeters squared. Again, a prism. So we're going to go 2 times 6 and 1.5. Order doesn't matter. 2 and 6 and 11. And then 2 and 11 and 1.5. And again, the order doesn't matter. So I'm just going to multiply it out. And that's 183. And that's inches squared. All right, that's a prism. Here are other prisms. So for other prisms, we need to understand the base and the faces. So the base is a triangle, and they match. So a triangle is half the base times the height, and the base and height here are 9 and 12. And there's 2 of them. So I'm going to multiply it times 2. Plus, we have 3 rectangles. So one rectangle is 16 by 15. Another rectangle is 16 by 12. And another rectangle is 9 by 16. Notice 16 is used each time for the different sides of the triangle. All right, I'm going to plug this in to my calculator. And I get 684. That's meters squared. Again, this is a triangular prism. So the triangle, they say it's 1/2. The height is 4.1. And the base is 12. And there's 2 of them. So I go 2 times 1/2 times 4.1 times 12. And then the rectangles. So one rectangle is 5 by 3. Another rectangle is 10 by 3. And another rectangle is 12 by 3. And then multiply that out. And I get 130.2, and that would be kilometers squared for the surface area. This is a trapezoidal. So we have 2 trapezoids, so 2 of them. So it's 1/2. The bases are 23 and 18, and the height of it up is 12. So those are the 2 trapezoids. And then we have 1, 2, 3, 4 rectangles. So one rectangle is 12 by 15. The top rectangle is 18 by 15. This side one is 20 by 15. And then the one on the bottom is 15 by 23. Again, notice 15 is a part of all of those. All right, let me put that in the calculator. A lot of crunching. I get 1,587 feet squared. All right, here's another trapezoidal prism. So we have 2 of them. It's 1/2 times the height and the bases. We have 10 and 18, so we're going to add 10 and 18. And the height there is 12.4. Plus the rectangles. So we have 18 by 9. We have 13 by 9. We have 10 by 9. There's one more I'm missing. We have, what's this one here? Oh, another 13. So there are 2 rectangles that are the same size. So another 13 by 9. I'll just write that here too. And then put that in your calculator. I get 833.2, and that's millimeters squared. All right, a triangular prism, so two triangles. So one triangle is half the base times the height. In case you don't know, the 2 and the 1/2 cross out, so it's really just 8 times 15. We could have done that before too. Plus the 3 rectangles. So one rectangle is 8 by 21. Another one is 21 by, oh, we got to figure out that size. I need the side, so I need to use the Pythagorean theorem. So I'm going to go a squared plus 8 squared equals 15 squared. So I'm going to go 15 squared and 8 squared and subtract those numbers. So 225 subtract 64. Oh, darn it. So those are both legs. Let's try it again. So I'm going to go 15 squared, that C, that's what I'm looking for. So I'm actually going to add them. It's not the hypotenuse. I'm looking for the hypotenuse. Let's try it again. So 15 squared plus 8 squared. And then I'm going to take the square root of that number, which I think is a perfect square. I know it's a perfect square. So that number is 17. So I need that number 17. So another rectangle here is 17 by 21. Which one did I miss? 15 by 21. There's the last one. How the shape of your base is, like a triangle, tells you how many rectangles there are. There's 3 of them, right? 3 sides to a triangle. And then multiply it out. 8 times 15 plus 8 times 21 plus 17 times 21 plus 15 times 21. And you get 960, and that is inches squared. Next shape, cylinder. So the surface area of a cylinder, we have 2 circles. So one circle is pi r squared, and the radius is 11. So pi r squared, and the radius 11, plus we have this belly. When you unfold, it's actually a rectangle. So the circumference, the formula here is 2 pi r. So 2 pi, and the r is 11, times the height, which is 26. So if we follow this, r was 11 and h was 26, and then use my calculator. I get 2,557.3, and that's yards squared. Next one, again a cylinder. Just know that this is the diameter, so divide it by 2. So 15 divided by 2, that's 7.5. That's what I'm going to use. The height, it's on its side, so the height is really the distance between the 2 bases, which is 9. And then the formula. So I'm going to go right here, surface area. So that is 2 pi r, which is 7.5, plus 2 pi 7.5 times the height, which is 9, using that formula, and then plug in. And I get 777.5, and that's meters squared. All right. It says if the surface area of this box is that, find the length of the box. So surface area, we're going to go 2 times 2 times 12. We're going to go 2 times that length times 2, and 2 times that length times 12. So that's the formula we're going to use. We know A is equal to 272. 2 times 2 times 12 is 48. 2 times 2 is 4L, and 2 times 12 is 24L. So I'm going to subtract 48. So I'm going to go 272 subtract 48. That's 224. And I'm going to add the L's together. That's 28. And then the last step, we're going to divide by 28. And you get the answer that the length of the box is 8. Number 12. Can of soup. A can of soup is a cylinder. So for the cylinder, the formula is that surface area is equal to 2 pi r squared plus 2 pi r h. And it says the soup can has a surface area of 51.84 and the diameter is 3. Well, if the diameter is 3, I got to divide by 2. So if the diameter is 3, the radius is 1.5. So I go 2 pi and then 1.5 squared. And then 2 pi and 1.5. And then I need to find the height of the can. So I'm going to solve this one step at a time. So 2 pi times 1.5 squared. So 2 pi times 1.5 squared. I get 14.1. Then I'm going to go 2 pi times 1.5. I get 9.4. Then I'm going to subtract 14.1. So 51.84 subtract 14.1. That's 37.74. And then the last step to get h by itself is to divide. So I'm going to divide by 9.4. And the height is about 4 inches when you do that. All right, is that the end? That's the end. Mr. G Math over and out. Great job for the lesson. Now let's do our homework together.